Hello, everyone, and welcome. I'm Jonathan Hill, and before I turn it over to Damien Vanderpool to walk us through all the new features in Femap 11.4, I'd like to give you a brief intro into ATA. So most of you probably know ATA either through our role as a Siemens partner and reseller or through our robust engineering services. And these two really go hand in hand. We have experience providing engineering services across a wide range of industries, and because of that, we're solving the same issues as our software customers every day, which really helps us provide exemplary support. So on the services side, our focus is on analysis and test-driven design. ATA is proud to help our customers meet their toughest engineering challenges, whether that's performing ground vibration tests on state-of-the-art aircraft, or helping to ensure the safety of theme park attractions, and also analyzing next-generation spacecraft and planetary rovers. Of course, being experts with Siemens PLM software helps us to do precisely that. Speaking of the software, this list shows the Siemens product lines that we use and can assist you with. We host a technical support hotline, and that is staffed by experienced engineers who are using these tools every day. You can contact the hotline either by phone or through our website. In addition, we can also help with license sales. We offer a variety of classes, and these range from introductions to Femap and FEA, all the way to more advanced topics like dynamic response, super elements, optimization, and more. The full schedule of available classes and upcoming classes can be found on our website. And I've mentioned it a few times now, but this is our website, ata-plmsoftware.com. As we've discussed, it houses the full list of upcoming classes and can also be used to contact our support hotline. It also has product information for the different software lines we support, links to download free trials, and at least in my opinion, probably the coolest part is the growing collection of free resources. So if you click on the yellow button at the top for free resources, you'll find white papers, training videos, tutorials, APIs, all sorts of things. And these are all geared towards what we hear back from our customers that they're interested in. So definitely let us know if you have any requests in this area. And I invite you to check out all the resources that are already out there after the webinar. But for now, I'd like to turn it over to Damien for the main event. Damien, all yours.
All right, thanks a lot, John. So my name is Damien Vanderpool. I'm an engineer at ATA Engineering, and I will be talking about what kind of updates and new functions there are in Femap 11.4. So first thing I'd like to say is that I tried to group it into different categories, and I'm going to be going back and forth between this presentation and Femap in general. So the first category that I'm going to talk about is under the visualization category. And there's two updates to Femap 11.4 for this. The first being this auto scale feature that is pretty nice. So in order to show it, I'm going to use this model right here that I have. It basically is some CAD and geometry as well as some meshing. It's kind of hard to see the details of this. But if we go to our groups and we show a little highlighting, you can't really tell what I'm highlighting, because it's a very small group in the middle of this, and it sometimes can be hard for the user, or more difficult than it needs to be for the user, to really figure out what it is they're looking at. So if I zoom in here, I can see that I have these RBEs being shown. But what the auto scale does, it's a nice feature, and it's going to zoom in automatically whenever you select your group. So you can activate that by going into this drop-down menu and showing the auto scale to show entities. You can also, if you don't like using it that way, go to Windows and show entities, and here it is. Or if you like to be fancy and do the shortcuts by doing Shift F12, you can go back to it right here. I'm going to use it through this drop-down menu. I'm going to do auto scale. It's now, if you go back, checked. If I go back and click on my group, it's going to automatically zoom in so I can easily see my group. And just for the sake of comparison, if we go back and I click the group now again, without auto scale versus with auto scale. All right, so that's one of the cool new features. The other is an update to the draw entity, draw erase entities up here that was, I believe, new for 11.3. So let's just say, for the sake of argument, I want to make a group of these elements shown here. You would click on the draw option. You would say, I want to select elements. And none of this part right now is new. This is just the way it's worked now for a little bit. I do this, click enter, and now it's only showing what I highlighted. Unfortunately, I have more than I wanted. I got the other side of this. Historically, when you would do this and you would want to reselect to get a smaller group, you do select elements and everything would show again. Sometimes it's not really what you want. So now this new feature is you can go to this draw erase selected area drop-down menu and deselect the default, which is draw mode select from all. When I do this, now when I do select elements, it's going to give me the option to select from what is being shown at this time. So I can easily just grab these guys, press enter, and now I just have what I want. And if you feel inclined, you can then make a group of this to save for later. So if I do Alt F2, new group, and then add these elements, I now have a new group of just those elements versus these guys. And you can see I'm actually zooming in and out based off of my auto scale that I have still checked. So with that being said, those are some of the neat little visualization updates that we have in 11.4. There's also one for meshing. So if we go back to this model, the meshing update is a nice little handy tool about auto-updating the RVEs when you update the mesh. So if we zoom in here on this part of the mesh, we have this bracket that has RVEs on 2 of them for now, but the mesh isn't really all that great. So what you can do if you want to update the mesh, you go to meshing, mesh sizing. We want to increase the mesh, let's just double it, and then you can select what you want to double. So if I want to select, let's say, this circle here to have it similar to this bolt hole, when you click on this curve, the RVE automatically updates along with the mesh itself. So if you look again here, you originally have 4 nodes along this curve and 4 RVE legs. You click it again, now it is doubled. And the whole mesh updates, and now the RVE goes along with it. Now there is a limitation to this, and it is an intentional limitation. Let's say I want to do it for this guy. Notice that this RVE does not have a leg for every single node along the curves. Maybe that's what the user wants, maybe the user forgot. But for this example, I'm going to click on it, this edge. The mesh or the bracket updates, but the RVE doesn't. And in fact, there's a message shown right here in your message window, potential rigid disconnect at element X and curve Y. Basically what it's trying to say is we didn't update the RVE because you originally didn't have that RVE connecting to every single node along that curve. And so they're just giving you a little heads up that if this is what you want, great. If not, you're going to work on this RVE. And so you can see if I go all around the sides, the RVE stays the same. With that being said, let's move on to a pre-processing functionality. For this, we have 11.4 has a couple of new options under tools. You can make a vector manager or a plane manager. So essentially what this does is that you can store, save vectors and use them later for any kind of manipulation or pre-processing or even post-processing that you want. And this window here, this vector manager, you can create a new one, you can show, you can edit, basically all the functionality that you would by basically defining a vector, but now you can save it and store it in your manager. Similarly, you can do the same for the plane. It looks pretty much exactly the same, although now it's a plane. So here, just to show this plane, it's at a 45-degree angle at the bend of this bracket. So to use this, I'm going to just project a node onto that plane. I go to project, I go to node, I'll click this RVE node here, highlight to make sure, highlight and show. Do that, and now let's go say, what do you want to project onto? I want to do a plane. Come here, and normally it would be like this. You have to define your plane. But if you go to Methods and Save, you now can use all the planes that you saved in your plane manager and select that. And now my RVE moves to that plane. So that's a nice little feature you can have as opposed to redefining it every single time, especially if you have a difficult plane or vector. Another option another feature that's added is, actually it's already shown, it's Function Table Editor. So if I hide this real quick, you've always had for a while now this function option here in your model browser. You can define it as you wish and use it for whatever it is that you want to use it for. You can use it for defining material properties or loads or anything like that. Now if you go to the tools, it is an editor that you can add to your list. And when you do that, this editor has options where you can load in functions, either ones that you've already created or ones that are stored in the library. You can also edit the functions and everything, or vectors once you get in there. And if you want to make a new function, they give you different categories from which you can define, if you want it versus time, temperature, etc. I'm going to load in the function that already exists in this model, bring it in here. And now these other options that were grayed out are no longer grayed out. This is to save the function, here's to copy, here's to edit, and here's just to clear it all together. Moreover, once you're in here, you can actually right-click in your table and add or edit the function this way. And so you can do eventually a combination of ramps, series, equations, or filling it in manually. So if I right-click and do ramp, this ramp definition window is going to pop up. I can either overwrite my existing data or add to it, and give you, how do you want to ramp it. So I'm going to say we originally went from 0 to 3. I'll say 4 to 6, going by 1. We originally already ramped it from 0 to 30. I'll just say going from 40 to 100. I want to add rows, add rows, and now there we go. We've edited our table and changed the ramp to whatever we want. And then again, you can save, et cetera, et cetera. So with that being said, we're going to go now to the next category, which is geometry manipulation. So this one is a nice feature that probably is going to save a lot of tedious tasks for some of you who ever work with geometry in Femap. Here we have a model that is just a bunch of tubes, but they're all overlapping. And I'm going to show this in wireframe view to make this a little easier. Essentially, what happens if we want to list our curves, and I want to click on those two curves and highlight them, you can see that they overlap, right? This is not necessarily useful if you're going to want to mesh this and going to want to have the nodes being merged and everything. So previously, you would have to break these curves individually, or at least maybe in groups and everything, but it was a pretty tedious process. Now there is a new option under Modify, Break, at all intersections. You can either select all, or you can highlight whichever ones you want. It opens up this GUI window, say which curves you want to say to intersect, and it's just going to do it automatically, that one click of the button. Now if we go back to look at these curves, I click those same two guys, and they stop right at that intersection point. Similarly, I can look at those two, highlight them, and as much as you want, you can see how they stop at all the intersections. So that definitely can save some geometry manipulation time there for the Femap user. So the next section, data mapping. This one's one that I'm not going to show you on the fly because it's kind of hard to show the benefit in a less than 1 hour webinar. So I'm going to show some slides instead. So essentially what they did is that they changed the algorithms which they seem to use to map temperature, anything, temperatures, pressures, what have you. And now it can be up to 1,000 times faster than it was before, which I'm sure for many of you is a pretty big deal. So they've also added different types of data conversions from the source model. You can do an average, max, min, controllable only, corner data. You can use settings from the active view, and they're still working on it to improve it even more for future iterations. They're working on matching criteria plots and contour plot options as well. But to give an example of this, this benefit of the new updates for Femap 11.4, they showed that we have as a model of basically a million elements model in which you have a temperature map or a temperature contour plot on it, and you're trying to map it to another model. Historically, in version 11.3.2 for Femap, this took over 5 hours. Now with this new version 1.4, it takes under a minute. So a dramatic improvement that you can see on the data mapping. Similarly, so now we're going to go to the next option, or charting, and now I'm going to go back to the Femap for this. There we go. So I'm going to use a couple models to show all the different kind of updates and nice little tricks you can do with charting. But for this one, I'm just going to show real quick these existing groups because I'm going to use them. We have the top nodes, which is the line of nodes on the top of this little plate, and the bottom elements. And the contours we're dealing with, or the results we're dealing with, are going to be von Mises stress. So charting, for those who don't know, for me it's here on the side. There's also this option here. You can turn it on and off. You can move this however you want. But I'm going to go to Data Series Manager and create a new series. And this window here now looks pretty different from what it did before for any of those familiar. Essentially, Siemens really tried to remove the clutter and kind of give you exactly what you need for each type of charting you're trying to do. So now there's a drop-down menu here, and you have different types of charting. You can see with each different type, the options from which you select change. Moreover, for each of them, there's a different tab for style that is now separated from the data. That way, and these are always the same regardless of the type, but you can set the style as you wish. So the first thing I'm going to do here is show a von Mises stress as a function of position. So my x-axis, I'm going to choose position on the x direction. You can see here, it's going to be along the side. I'm going to want to choose my plate top von Mises, and I'm going to want to do an average nodal data and select my top nodes group. So I click OK, it's done, and now here it pops up. And now you can look at the von Mises stress as a function of nodal position in the x direction. And it's kind of nice, handy little thing you can have going on here for post-processing. I'm going to give you a couple more examples. I'm going to move this from the chart. You can also transform data. So I'm going to do essentially the same thing, but now I'm going to get an output set that is given originally in the local coordinate system. So I'm going to use, let's say, plate X membrane force. And I'm going to want to transform and show it first in the basic coordinate system to kind of get a global X force. And I'm going to select my bottom elements. And here we go. So I do that. And here we go. We have what's kind of similar, but it's actually, here you can see in the title, the plate X membrane force transformed to the X coordinate system 0 versus X. Now, I'm just going to copy this plot and actually chart and actually show it in the local coordinate system. And now I'm going to deselect plate. Deselect the basic coordinate system and do OK. And now you can see here in the blue the same thing, plate X membrane force, but not transformed. And you actually can see the difference in the X membrane force as a function of local coordinate system and global coordinate system. And so this is a way to compare and transform data and see different things that you get. It's a nice little feature. Now going into this model, which has modal data in it, you can also have complex charting and actually see them at the same exact time. So if we go to this output nodes group, just to again show where I'm talking about, the group we're looking at are these 3 nodes here. We go to charting, go to Series Manager, New Data Series. This time, as opposed to vector versus entity, I'm going to choose vector versus set. And I'm going to want to look at the translation and the T3 for this frequency to that frequency for the entire study, which is a range of frequencies from case 1 to case 15. I'm going to want to choose my group, or you could easily just select the nodes and elements you're interested in. And I'm going to press OK. And now we have here the translations for all 3 nodes. But I want to look at it for the complex, phase versus magnitude. So I'm going to go to Chart Options. And here under Complex Plot, choose Top. OK. And there we go. For these 3 nodes, you're looking at both the phase and magnitude of the T3 displacement as a function of frequency. So, and Femap will do this for any output vector that can take complex data. And so it's pretty handy and pretty nifty if this is the kind of thing you're interested in seeing. So I'm going to remove all these guys to show one more type of charting. This time I'm going to show an expanded complex, and this is good when you want to basically show a double complex data plot, or rather you want to show magnitude phase data. So I show the expanded complex. I'm going to take my case 1 single output set. I want to look at data of interest, which is for me again T3 translation. This time I'll just look at a single node as opposed to all 3. But I want to look at a phase increment of 10 degrees. Click OK. And here you go. You have the T3 translations versus a phase from 0 to 360 degrees at 10-degree increments. And you're able to plot that, and if you feel so inclined, you can always go to Charting Options for any of these and go to Labels Manager, show Max, Min, and it's going to show the max here. So these are kind of just different ways you can use charting to post-process quickly and on the fly while you have your data. And if we go back to the overview here, the next section is going to be the updates to the Nastran solver support. So this is going to be another one that I'm not going to show in Femap, but just on a slide. So the enhancements they have is when you have the param post -2, it now reads a nodal output in the basic coordinate system. You can have strain curvature output support. There's a lot of enhancements when reading in files about a DMIGs. For those of you who still use CLS elements, you can now keep and cycle CLS1s as opposed to automatically converting to CLS2s. And for those that do some thermal analysis, you can use the ZTOL entry that's supported now with Nastran radiation analyses. So going back here, Siemens has created a new function that is used only for APIs. So I'm going to have a few slides talking about it and then kind of show it in action. So the function itself is called Solid Centerline Finder. It literally looks like this, FE solid extract center lines, if you would use it in the API. And what it does is that it takes geometry, and as the name kind of implies, it'll automatically create a curve at the center line. That way you can easily use that curve for meshing purposes when you want to mesh beams. Moreover, it actually also creates property IDs. And the properties are defined, fully defined with their areas, moments, inertias, and everything you would need to have a fully functional PV moment. So in this kind of picture you showed here, there was a tube of a complicated structure. This is after you already used the function, and now there's center lines going all the way through. And then you can easily mesh and have a nice mesh for beam elements very easily done. So I'm going to go to this truss assembly model here. You can see here we have, if I do wireframe, we have a whole bunch of tubes, similar to what I showed in the PowerPoint, that are all connected. So as of now, this model has nothing in terms of finite element alpha. There's no materials, no properties, or anything defined. It does have a bunch of solid geometries defined representing all the struts. So I've already added in this API that ATA created using the tool, the Spline Centerlines tool. And this API is available on the website that Jonathan Hill mentioned earlier. It's free to download. It's called Beam Centerlines 2 Group. And so what this API does, it first asks you what geometry, what solid geometry you want to create centerlines for. So for this this model, I just want to use all of it, so I'm going to select all. And then it's going to have this window pop open, and it's going to ask, am I only using tubular solids or not? The reason for this essentially is, from what I understand, if you only want to do the tubular solids method, it's going to create as little property IDs as possible. So if all your geometry has the same cross-section, it will make a single P-beam property card. Whereas if you do the no, it's going to make a property card for every single solid geometry that you are creating centerline for. And then obviously, as the name also implies, the yes would only work for tubular beams or tubular geometry, whereas the no can work for everything, you know, L brackets, I-beams, or sorry, L-beams, I-beams, things like that. So this model is all tubes, so I'm going to click yes for here. Do OK. It's going to want a material property. I didn't have one defined in this model yet, so I'm just going to say steel, press OK. It's computing, and now all of a sudden I have properties defined. I have two properties in particular. So if I go here and edit, you can see the area, moments of inertia, everything is already defined. Go to shape, you can see it actually has the tube cross-section correctly defined in terms of the outer and inner diameter, and it's ready to go for Nastran. Moreover, this API creates a group of all the curves that it just created. So if I do a highlight here, you can see I have a line here that's created of all of the center lines for all of the geometry that I just asked the API to create. And now I could easily just, go to mesh and mesh on these lines and have essentially this geometry in finite element form. Now I'm going to show another example of this API, but this one is for a complex geometry that it doesn't have really any tubes. Once again, nothing is defined here in this model yet, but we do have hundreds or so of solid bodies. I'm going to use this tool again. And here, I actually don't want to extract center lines for all surfaces or for all geometry because not all of these guys are beams. I'm going to do all at first, but then get rid of the guys I don't want, namely these two plates here. So that way I can only select the geometry I want, do OK. It's once again going to pop over to this. None of mine are beams, so I'm going to do no. Click OK. Once again, I didn't have the material defined. Let me just define one real quick. And it's going to take a little bit of time because there was, well over 100 geometrical solids that it's going to do, and it's going to make a property ID for each one of them, pretty much. So it's going to take maybe 30 seconds or so for this example, if memory serves. But in the meantime, you can see originally I didn't have any materials or properties defined. There's no plus mark next to it, and now, boom, they popped up. Expand this, and you can see we got a lot of properties defined. I'm going to edit it again just so you can show it's automatically filled out, and it knew this particular guy was an L-beam. So it's defined it correctly. Now, one of the limitations of this function, unfortunately, is, show first in the slide form and then show it in the Femap. There's two main ones that it has. One is that if you have a non-circular cross-section that might have different cross-sections over the length of it, it's going to use the cross-section based off of the longest curve. So essentially, I guess if you have one solid body that might, let's say, paper or something like that, it's only going to pick one cross-section. And it's going to do that based off of whichever curve with the longest within that solid body. Another limitation is that if you have any kind of curved surface, or rather a surface with multiple curves, it doesn't really handle it too well yet. So here's kind of a picture of what that kind of means. You have two beams. One is a straight line. When you do the cross-section, when you use the tool, it works great. And when you have another one straight for a while and then curves, it doesn't really know how to handle that. So with that being said, that limitation is shown in this, let me actually do a highlight. In this model right here. So you can see it made these lines for pretty much most of it, everywhere I kind of wanted to, but I had a couple issues. You can see here it didn't make it on these little pieces. And so, you're going to want to double check when you use this guy. You want to make sure that you only, for those parts that it doesn't make, that doesn't connect, you're going to want to add that manually. Also, obviously, all these different components were different solid bodies, and so they're not going to be merged together. So when you're doing stems, you're going to want to look into that. But in general, this does save you a lot of time by finding the center line for all the geometry that you need. So with that being said, we're going to go to the last update that we're going to talk about today. And this is actually not an update to 11.4, but rather a macro that ATA created for projects we've used in the past. And what it does is that it allows you to preview a group in Nastran format. So because of that, it's called Prev Group Bulk. So it's preview the group, shows it in bulk format. And what you essentially can do is that you just have whatever group is active in your model, select that API, and it's automatically going to pop up a Nastran bulk file in the text editor of your choosing. So to see that at work, we're going to go back to this model. If you remember, we have two groups here. This one was the elements here, I believe. Yeah, okay. So I'm going to go to Custom Tools, Preview Group Bulk. I already have it in my toolbox. And it's going to automatically pop up this window here of how it would look like in Nastran format. So my group contained a whole bunch of elements, and it shows it there in its nodes, and the basic coordinate systems of the model. And if I would suddenly now activate my other group of the RBEs, and I show it again, it's going to make a group of, or it's going to get a bulk file of just those RBEs. So you can do this just to verify that it's your group that has what it wants. You can do this to create an individual bulk file that you can then use as an include for a DAP file, or there's a bunch of different applications for this that can work pretty easily. And it's a pretty nice and helpful tool, because historically, at least the way I've done it, is I would always have to make an analysis, create a new analysis, and just have only the group be part of that analysis, the group that I wanted. And then I can do a preview input and get basically the same thing. But now I can skip that whole process and just use this API. Now, the one thing that I know about this API is that it was written broadly intentionally. And so if we go, sorry for this, I'm just going to find my where my API is stored on my computer. And all right. So here's the base file as it saves. If I open this file in the text editor, one of the things you're going to want to do is specify where your text editor is and which one you want. So for me, I use PFE32, and so I had to specify where that software is installed on my computer. That way it knew which text editor to open. Otherwise, this API won't work. You also can specify the files that I was showing. The preview files are all being saved to my Scratch drive. So if I'm going to go back here, go to my Scratch drive, you can see all of these files that I've created with the preview over time. Essentially, the naming nomenclature is, it's my H drive, tutorials folder, Femap folder, and I was using the meshing mod fem, and I was showing group 3, and that's kind of the nomenclature that it uses. So you can either use this preview file and just copy and paste it to where you want if you want the bulk, or when you do the preview, manually copy and paste, et cetera, et cetera. Then that actually, yeah, that's it. Oh, and one important note is that this macro, similar to that API that ATA wrote for that centerline function, is also on our website and available for all of you to download and use. So with that being said, I think I'm going to unmute Jonathan Hill and see if he has anything he wants to add. But that's basically everything I'm going to present, and I'm going to open the floor to any questions. So actually, I'm going to unmute everybody for that reason. So if anyone has any questions, feel free to ask. Oh, did I unmute? No, I did not. Hold on. Unmute all. All right, now everyone's unmuted. I did see one question pop up in my window, but I was talking, so I didn't actually get to read it. Let's see where. If you can repeat the question, or I can try to. Oh, here under chat. Okay, so. All right, yeah, I see the question. So someone asked AP. Okay, so someone asked if I have a separate scratch drive or a separate steady state or solid state scratch drive, SSD. We do, yes, but I don't think it doesn't affect, I guess, any of these features that we have. And as for the center lines being an API format, this is only a function for API. I think that was made that way. Because they're still working on it, that's true, and they wanted to make sure people can use it. But I also think it allows the flexibility for any kind of any Femap user to use it as they please. For example, the API that ATA made, we decided, our engineer who created that API decided to add the groups to select in the beginning. And once the program asks. Let me go back to it. The program asks which ones you want to do. This was something that we added API, and then also the whole feature of creating groups in the end. You can make your API more complicated or less complicated, however you want. But it's as of now, yeah, it is a function within this. So another question: can this inline feature produce non-circular beam profiles? Yeah, actually, that was what we did for this model. So if I show the entire model again, it was all L-beams, and all of these properties, if you look at them, are actually L-beams. So it can be used for circles, for tubes, for solid rods, for L-beams, for I-beams, all that good stuff. I think that is all of the questions that have been chatted to me. Does anyone have any questions they want to ask over the phone? All right. Jonathan, is there anything you want to add to close out, or?
No, so thank you very much for a great webinar on what's new in 11.4, and please let us know. You can contact us by phone, on our website, a number of different ways if there's anything we can do to help you guys out. Thank you so much.
So there was one question that popped up asking when will 11.4 be available?
11.4 is already available. You can download it from the GTAC site today.
All right. Okay, well, thank you very much, everybody.